recently came across a need to build an application like this where we had some scrolling content at top, and then we had a little filter bar that would control a filter of the table items below, and then a scrollable table view. And we're looking at this on a iPhone 4, and there really doesn't leave very much room at the scrollable part at the bottom here. And what we'd like to be able to do is sort of, as we're scrolling up in the content, that we could move the table view a little bit taller in the viewport. Now this is similar to an effect we see in the MLB app. Here we have some scrolling content at the top where it shows the game schedule, and then the content below scrolls up, and you can see it just scrolls on top of the game schedule portion of the screen. It remains static in there. And that's kind of the effect that we're going for. So here I've got my application, I've got my nib open, and you can see here that I've got a scroll view at the top for the pictures that scroll horizontally. Then I've got a table view at the bottom, and I've got a view that I'm calling a filter view here in the center. Now the filter view right now is just a plain view, but we're going to need to make that a table header so it scrolls with the table as we scroll up. In addition, if we take a look at the outlets here, you can see that I've got a filter view outlet, I've got my scroll view outlet, I've got the table view outlet, the standard view outlet, of course, and then the delegate and data source for my table view is set already as my view controller. So going into the code here, what we need to do is pull that filter view out of the view hierarchy and make it our table header. So I have a little method here that I'm going to do that. The first thing I'm going to do is calculate the Y position of the filter view, because that's going to be the table view's new Y position. And then we're going to calculate the height of this filter bar, because we need to extend the height of our table by that amount. So next we need to pull the view out of the view hierarchy and assign it to the table's header view, and that can be done in one step here by just associating it with the table header view property. And then finally we need to pull out a CG rect called table frame, and we're going to use that to change the origin and the height of our table view and then reset it so that we can have our table view account for the filter view's size. So after doing that, you can see that when I scroll the table, the filter view is coming up with the table, so it's now part of the table header view. So that's step one. And next we need to actually implement the UIScrollView delegate protocol. And it turns out that we're already a ScrollView delegate protocol class, because UI table view delegate also implements UI ScrollView delegate. So all we have to do now is implement ScrollView did scroll here. And then once we've done that, we can write our code here to do the custom scroll behavior. So we need to take a look at the scroll view's content offset, and we need to check to see if we're scrolling up or down. We can do that to see if the content offset is greater than 0. That means we're scrolling up. And then we have a couple of Boolean variables to see whether or not we're going to adjust up or down. We're going to adjust up if we're scrolling up and there's room to scroll up. And so as long as we have any room in the Y direction greater than 0, that means we can scroll up more. Adjust in the down direction if we're not scrolling up and there's room to scroll in the down direction. So we're going to do that by checking the origin Y, and we're just going to pin it just below the scroll view's height. So that's about 200 pixels. Then we just want to calculate the adjustment amount, which is going to be the Y value that we're scrolling by. And that can be negative, so we're going to take the absolute value. So here, if we're going to adjust up or adjust down, we're going to do some calculation. The first thing we're going to do is we're going to adjust the view's frame, move the table view up by that offset amount, and then increase its height so it still accounts for the full frame of the view. So we're going to calculate the frame. We're going to set the origin Y and subtract that adjustment amount. Then we need to make sure that we don't go too far. So we're going to do a max of 0 and the frame's height. And then we need to do the same thing for the size of the frame. So we're going to calculate the height. We're going to increase it by the adjustment amount, and then also do another calculation with min of the view's full frame and its current height to make sure that it can never go taller than the full frame. And then finally, we've already accounted for this content offset, so now we need to set the content offset back to 0 because we haven't actually scrolled into our content. We've just increased the area of our table view to account for that content. So we keep it at CG.0. So now if we're adjusting in the down direction, we're basically going to do a similar section of code. So I'll just copy and paste that. And we want to this time add the origin y and then subtract the height. The origin y needs to be a max or a min of some value here that we're not really sure yet. So I want to keep track of the table's original frame. So I'm going to create a property here to store the CG rect that the table is at the time of rendering. So when it gets loaded from the nib, we're going to set this property so that we can use it later on. Now back in the scroll view did scroll, we can use that value to make sure that we never go below that point in the frame where the table was originally. And we need to do the same adjustment here for the height. So we're going to subtract the adjustment value for the height. And then for the height of the table, we're going to do another safety check to make sure that we don't ever go greater than, or smaller than, rather, the original height. And once we've done that, we have a working example so we can try it out. And here you can see that as I scroll up, the content at the top is remaining static, but the table view is increasing in size. And you can tell that it's doing this by watching the scroll indicator on the right. You can see how it's changing its scale because there's more height in the content and less to actually scroll through. And once we get to the top, we've got a full screen scrollable table view. And as I scroll back to where we're at CG.0 for the content offset, you can see that we're pulling down and shrinking the height of the table view to account for that. And then you get the default springy animation back to its point there. So the only downside to this solution here is as I'm dragging and I sort of let go in the middle of it, we're getting the default deceleration behavior, but it's sort of snapping into place. And that's because it's setting the content offset, causing the table view to scroll at an animation or at some deceleration rate. And then we're doing some math to reset that. And so one thing that you might consider doing here is keeping track of whether or not you're decelerating. And then in the scroll view delegate protocol, there's a scroll view did end decelerating, which is a good way to turn that off. And of course, we need to know where to turn it on. So there's a method on UIScrollView called scrollView will end dragging with velocity target content offset. And if we just go ahead and log what the target content offset is here, we can get an idea of what the table view is going to come to rest at. And then there's the complicated task of trying to sort of compensate for the animation that we're doing versus the animation that the deceleration is doing. And here we actually need to dereference this pointer because it is an in-out parameter, because we could potentially adjust the target content offset to have it come to rest at a different spot. So we might just check that we're decelerating yes, and this is where the sort of undesirable hacks come into place, where you might just start playing around here, that if we're decelerating, maybe I just make the adjustment not quite as powerful if we're decelerating. And if I do this, it sort of masks the problem. You can see that it seems a little bit more natural, but it still does snap to place. It just doesn't do it with such force. But you still have the problem that when you stop decelerating, you can see that real big snap at the very end, which is really quick. Once we stop decelerating and it's sort of going to do the bounce back, that does it at full velocity, and it just looks really unnatural. In addition, if you catch it while it's decelerating, then you're stuck in a position where each scroll point is actually only going to scroll the view 1/3 of a point. And so you get this feeling that it's sort of sluggish underneath your finger. And when I reached this point in implementing this, I was scratching my head as to what the math would be to make this work. And it seemed like I was fighting the framework every step of the way. And so it was at this point where I decided that this solution probably wasn't the best one. So I decided to go back to the drawing board. After a quick break, I decided that this might be better if I had a scroll view for the entire region of the screen. And then I would just figure out how to keep that scroll view at the top underneath the table view and pinned to the top. So here in the code, I'm just going to go ahead and delete some of the code that we wrote prior to this so that I'm not worried about making it work with all that in there. So we just go down to our scroll view, did scroll, and we're just going to delete all of this content, all of the deceleration handling, and all of the adjustment code. Now at this point it might be good to create a branch in Git so that you don't lose this for good, but that way you can try it out without worrying about breaking stuff. So the first step is to create a scroll view. So I'm going to create a property here. And I'm just choosing to do this in code instead of an interface builder because I already had the code in Interface Builder laid out exactly how I wanted it, and it's pretty easy to wrap something in a scroll view in code. So I'm going to create something called an outer scroll view, and I alloc init with this with a frame, and I'm going to use self.view.bounds as my frame. Finally, I'm going to set the delegate to self, and you'll remember that we're already a scroll view delegate, so that will just work. And next, I need to make sure that I can rescale our table so that our table is no longer scrollable. And we can do that by resizing the table's content size, or rather the table view's frame, to equal its content size. Now to do that, I need to make sure that by the time view.load is run, that we've already reloaded all the data and we know how many cells there are, how many sections, etc., so that we know what the size is. And so I'm going to calculate the table frame, and I'm going to make its height the same as the content size's height. And this effectively disables scrolling inside of the table view because the table view is exactly the height of its content. Next, I want to add these views to the scroll view instead of to the main window. And I can do that by adding the scroll view, the outer scroll view's subview. So we're going to add self.scrollView to the outer scroll view, and then we're going to add the table. And we want to do it in this order so that the table is on top of the scroll view once we scroll it on top of it. And then finally, I want to add our new scroll view as a subview of our main view. And if I run this, try and scroll in this area at the top, it still scrolls left and right, and I scroll the table, but you can see I've got a problem. It's not actually scrolling up. In fact, it's really preventing me from scrolling. It seems like it's just the bounce animation of a table view when it comes to the end. So the problem is, of course, that I've forgotten to set the content size of our outer scroll view. And so I need to do that here, and that's going to be the height of our top scroll view plus the height of our table view. And once I set that on the outer scroll view, then it should be able to scroll through the content. Now when we run the application, you can see that it's scrolling through the entire content. Now of course the picture at the top is scrolling up with the content, which is fine. And we actually just need to make sure that this content at the top stays fixed. So let's go down to our scroll view, did scroll. Now you have to remember that we now have two scroll views that are delegates for this controller, that this controller is a delegate for. So we need to check to make sure this scroll view is the outer scroll view that is the one being scrolled. And then we need to calculate the rect, or rather reset the rect of our top scroll view equal to the content offset of our scroll position. And that way we can always keep its Y value fixed to this content offset, and that will appear to have it fixed at the top of our frame at all times. And because this view was added before the table view, when the table view goes on top of it, it will actually slide over it rather than underneath. And so this is the effect we're going for, and you can see that as I swing I flick this all the way across from up to top to bottom, or bottom to top, it just flows naturally like any scroll view should. And we don't actually have to fight with any kind of deceleration problem because we were messing with the content offset and adjusting the frame accordingly. Now there are a number of lessons we can take away from today's exercise. Now the first, while my first solution was clever and it was actually technically possible, I wrote a whole lot of math and frame calculation to make sure that we could adjust the frame and account for that adjustment by resetting the content offset back to 0, and thus making a table view grow and shrink. However, that interfered with other parts of the framework. And I actually spent a significant amount of time trying to fix that and just coming up with poor solution after poor solution and code that really made that complicated code even much worse and difficult to understand. And I ended up taking a break and coming back and solving the problem in a much cleaner way, a way that didn't make me fight the framework. And I think the solution is way easier to follow, and it's just a more robust solution. And so I think it's important to always make sure that if you're stuck on a problem, first of all, take a break, and hopefully the solution could present itself to you when you come back to it. And then the other lesson is just to not fight the framework. Try to do things in a way that is going to provide least friction so that you can still accomplish the same idea. There's multiple ways we could go about doing this, but ideas that don't involve complicated code that might be difficult to maintain and introduce little subtle animation glitches later on. Well, I hope you enjoyed this episode of watching me fumble through a complicated solution and then fixing it up with a cleaner one. And we'll see you again next week.